Okay. So take a second and see if you can draw the next three, 8, 9, and 10. Let me remind you, a quartic looks like either a W or an M. All right, this one I've got one real zero and two non-real zeros. So might look something like that. This one's my real zero. My other non-reals are happening up here where this bend happens. Quartic with two distinct real zeros and one double root. That means I'm going to have a bounce. It doesn't say if it's positive or negative, so it could be facing up or down, but it's going to have a bounce somewhere. So it could look like that. And this one is quartic with two distinct real zeros and two non-real zeros. So it could look like this. Oh, wait, the other two are non-real, sorry. It doesn't pass through. Something like that. Or it could be upside down because it could be an M. Okay, is everybody sort of okay? So far, so good? Now we've got the reverse. They want us to look at it and tell what we have. So I can identify zeros is where it touches the x-axis. So I have one right here and I have one right here. So this is one real root. And this one is one real double root. Now I can tell by the shape of this, it is cubic. So I need to be accounting for 3 zeros, and they are all 3 right there. 1, 2, 3. Number 12, what shape is it? Is it a quadratic, cubic, quartic, quintic? Quartic, right? Which means I need to account for 4 different zeros. So right here, I can see that's a double root, and those are real because I can see them. One real double root. That accounts for 2 of them, 2 of the 4. The other 2 are happening over here where this bend is taking place, but they're not touching the x-axis. So it's 2 imaginary. So that's all 4. This one is quartic. What can you tell me about this one? There's no real zero. So they're all 4 imaginary. And you're right, it's an M. All right, so this last one, what degree is it? 5. Yeah, it's quintic, 5, 5th degree. So, okay, so I can see 1, 2, 3. I have 3 real roots. None of them are double because none of them bounce. So what about the other 2? 2 imaginary. All right. So now we're just going to solve to find the imaginary roots. So looking at number 15, I can look at it and tell you one of them is real, and I can see what it is because it's clear. It crosses at the exact place. It's -4. I have one real zero, and it's at x equals -4. I am going to use that -4 to synthetically divide. Remember, it should come out to be 0 because I'm looking at it. I know it's a 0. That gives me my factored function. So this is going to be x squared minus 6x plus 10. That's my first factor, or that's the factor I found. They gave me the x equals negative 4 by the graph. As a factor, that's x plus 4. Now I have to find my other two zeros. So I'm going to use the quadratic formula just like we did on the front page. Plug it in. Negative, negative 6. So I'm just plugging everything into the quadratic formula and simplifying. I am going to use my calculator to simplify what's under the radical. It should come out to be a negative number. It does. It comes out to negative 4. So I get 6 plus or minus the square root of negative 4 over 2. So 4 is a perfect square. It just happens to be imaginary. So I'm going to get 6 plus or minus 2i over 2. Can simplify all of those outside pieces. So I get my other two zeros. These are the complex ones. 3 plus I and 3 minus I. So that accounts for all three zeros. There's the first one is the x equals negative 4, the second one, and the third one. Are we good? All right. So on 16, it looks like, I'm not positive, but it looks like that's at 1.5. But to be sure, I'm going to plug it in my calculator. Oh, look, it's already in there from 7th period. That's so nice. I'm going to plug it in my calculator and do a trace to find it for sure. And it's at 1.5, which is 3/2. So my x equals 3/2. So I'm going to synthetically divide with 3/2. So drop the 2. 2 divided by 2 is 1 times 3 is 3. Add straight down. Get negative 8. Negative 8 divided by 2 is negative 4 times 3 is negative 12. Add straight down. And that's 58. 58 divided by 2 is 29. Times 3 is 87. Okay, really quick, I'm going to show you this up here. Remember, because I'm going to write my factored function. If I write this as a factor, that would be x minus 3/2. But we don't ever write it that way. They always take this number and move it up to the front. So I'm going to write it as 2x minus 3. That's the same thing as x equals 3/2. So my factored function is 2x minus 3 times 2x squared minus 8x plus 58. And now to find my complex zeros, I have to use a quadratic formula. Okay, I'm going to plug all of that stuff in the calculator. Negative 40? Negative 400. 400, that's what I thought. Which is a perfect square, just happens to be negative. So I get 8 plus or minus the square root of negative 400 over 4. 400 is a perfect square. 20 times 20 is 400. So it's going to be 8 plus or minus 20i over 4. Everything on the outside is divisible by 4. So that would be 2 plus 5i, and 2 minus 5i. Notice your complex zeros are always just conjugates of each other. 3 plus I and 3 minus I, 2 plus 5 and 2 minus 5i. They're always going to be conjugates of each other. All right, we're going to stop right there. The back page we will do tomorrow. And then Thursday, we will have a concept quiz. Okay, when you get back.